welcome back, guys. We are busy with some mathematics, and for grade 11s, we are doing functions. We're going across the board on functions. So I hope you guys are so ecstatic for that, and you've learned enough already. So we're going to go on to some more. As you know, we are always doing more because this is so that you can learn more and learn extra. Over to you, E.T.
Thank you, Katleho. You know, one thing our viewers must get used to is that when you're dealing with functions, you cannot divorce it from transformation.
Yes,
guys.
that's it.
Definitely. All right, let's move on and do some more periodic functions before we move on to non-periodic ones. One more transformation that I wanted to attend to is reflection. Here I have it in combination with the scaling as well. So I have that y is equal to minus tan of 2x. All right. And if I were to sketch that, I would have to remember what the parent graph looks like. The parent graph for a tangent goes in that direction with those asymptotes that I pointed out earlier on. All right? But now, you are going to reflect this. The moment you see a minus in front of a function, you know that that function has been reflected about the x-axis. All right? And another tricky thing is the 2x. We're used to tan x. Suddenly, we've got tan 2x. How do we deal with that? This is going to affect our period. It's going to affect our period. I'll show you an expression that will always help you when it comes to a period. All right. And I did say we need to reflect that. Before we reflect it, let's scale it first. Now, what you'll notice is we were scaling in the vertical direction when we multiplied, when you saw a coefficient in front of the ratio itself. Now you've got a coefficient inside the ratio, sort of a coefficient on the variable, the x variable. So how is that one affected? There is an expression that I'm going to write here that you can always use. If your period is 180 degrees, it is going to be equal to 2x at the end, and you're going to have x equals to 90 degrees as your new period. Okay, initially remember we had 180 equal to x. So x was the period. Now, in this case, the period becomes, in fact, let's put it this way. The period will always be the period for the parent function divided by b. Now, b being the coefficient of x. All right. So that would be bx in this case. So that would have been y equals to tan of bx. So you just take the value of b and divide it into the period that you have. So you do the same if it was the sine and the cosine, but you would have to use 360 as the period. All right, so this tells me every 90 degrees, I will have this graph. In fact, let's take it from this point here. All right, so if a period, remember this thing repeated every, all right, that was a 90 and a 270. Now it's going to be half of that, 45 degrees and 135 degrees. At 90 degrees, okay, let's see. So now what you'll have is a graph that would be like that, but this has to be reflected. This has to be reflected on the x-axis, and maybe I should have kept the dots here. Let's keep the dots. and use the solid 4. Right, let's see. So this would have been the parent graph, but once you reflect it, it then, every y value becomes, changes sign, and this thing becomes a graph that goes in that direction. All right? And in this case, that was 90 degrees. So that goes up to minus 45 degrees. Every 90 degrees, you've got that. So from here to there is 90 degrees. Again, at 90. Your graph will look like that. All right. I hope that gives a picture of how the coefficient of x affects the period, and how the minus in front of the ratio changes reflects your graph. All right, let's move on to the next one. I think that's good enough there. If we move on to the next one, we take one more. Let's take the third example on trigonometric functions. And this time round, we're going to look at translation, vertical translation. All right. So if we have that y, your function is y equal to sine x plus 3, all it means is that your original function, which was like that, has been shifted. If this was 1 unit there, it will have to be increased by 3 units, and it will end up at 4 units. All right, so if it was 0 here, you add 3 units, you end up at 3 there. All right? And over there, if it was 0, you end up with 3. So you just plot those key points quickly, and you will be able, from minus 1 now, from minus 1, if you add 3 units, that's 1, 2. The third unit, if this is 3 here, 2 will be somewhere there. 2. Okay. So this will be the new point corresponding to that. Finally, if you had a 0 here, you're going to take this up to 3 units there. There is the new shape that we are looking for. And this is now the graph translated by 3 units upward. All right, we've drawn it. Sometimes you'll be asked to state the domain and range. In this case, we didn't specify, but we have drawn it up to 360 degrees. 0 degrees to 360. The domain is x from 0 degrees to 360 degrees. And the range, in this case, it's from, notice now, it starts at 2 and ends at 4. The graph does not exist below that level, and it does not exist above that level. Okay, so the range is where y starts at 1 and including, of course. That equal sign means, it's included, and that should be less than and equal to 4. That would be the range for our function in this case. And let's move to the next one. Yeah, I think we've covered what we need to cover there. Next one, it's another type of translation. That we did a vertical translation. Now I'm looking at a horizontal translation. You will see that I'm going to affect the x because that is the x-axis. So if you have y equals to cos of 90 minus x, what is going to come out is that this determines by how much you have shifted your graph in the horizontal direction. But then again, notice that you've got 90 minus x, which is not the same as x minus 90. So usually the form that comes up is y equal to, let's say, cos of x minus some angle, something like that. All right? In this case, it means therefore that you have got cosine of, if I put it as, let's raise the eraser there. Okay, so if I want to write it as x minus 90 degrees, I will then have to make sure that there is a minus outside that bracket. Okay, so it's like I've got cos of minus an angle. Cos of minus an angle ends up being the same as cos of that angle. So remember, we've got all students take coffee. That is for our ratios. A quick reminder. So if an angle is in the negative direction, you are beginning to measure in the negative direction, that is clockwise. Then in the first quadrant, this is an acute angle in this case. In the fourth quadrant, our cosine is positive. So that angle becomes, our angle in that case, it becomes positive, I mean. All right, so that being the case, all right, I will need more space here. There is a lot of writing here. We said y is equal to cos of x minus 90. And we said it is the same as cos of 90 minus x. All right. So what we had was a cosine graph that looked like that. All right. And you will notice that in front of the cosine, there is no coefficient that is scaling this up or scaling it down. So we still have 1 as our amplitude. And yes, it is symmetrical about the x-axis. And this is because there is nothing added to, after the cosine ratio. Minus 1 there. Right. So now we are going to translate this thing horizontally 90 degrees. So we had a 90 degrees here and a 180 there, 270, and finally it was a 360 degrees. Now we're going to take this graph and shift it horizontally. Now, what you're going to notice is, although it says x minus 90 here, we take this as a movement in there. Excuse me, that's let's get a rubber there. All right. So this is now going to shift in the right direction. So when you see a minus there, it's going to shift to the right. Okay, rightward shift. Okay. If it was positive, it was going to be a leftward shift. I will have time to explain that sometime, but that's how it is for now. So over here, we're going to shift it to the right, 90 degrees. So in other words, what used to be a peak at 0 degrees here will actually be shifted by 90 degrees, and that will be our new peak. And followed by that will be what used to be 0 here at 90 degrees will be 0 at 180 degrees. You'll see this has been shifted 90 degrees again. So every key feature is then shifted by 90 degrees. Over there by 90 degrees as well. And you're going to end up with a graph. This one is here. You now have a graph that looks like that. So what used to be, if I can just extend it to that side, minus 90 degrees, now corresponds with 0 degrees because we have moved it 90 units. Now, what you'll notice therefore is that cosine of 90 minus x is the same as sine of x. And you'll remember from when we were defining the ratios that indeed complementary ratios say sine 90 minus theta, let's say, is the same as cos of theta, or cos of 90 minus theta will be the same as sine of theta. And this shape is exactly, I mean, it's evidence to exactly what we are saying here. So this is the graph of y equals to cos of x, 90 minus x, but it's also the same as the graph of sine of x. So that's what horizontal shift does to the graph, to the original graph, the dotted graph in this case. All right, so that's just one shift. Let's move to another example.
Iti, before you
the
do
same
another
questions.
example,
Yeah,
must we go for a quick ad break?
yeah, we can do that.
Okay, let's do that.
Yeah.
Let's go for a break so that the next question can be started whole, and just so that you guys can also get refreshed, maybe move around, maybe just get revitalized, but be right back.